Welcome to Natural Gas Project. Producing natural gas from CO2 and hydrogen. CO2 production. CO2 of a flue gas stream, from a power plant for example, is separated by a solvent such as an amine in the absorber. The product of this column loses heat to the recycled solvent which comes from solvent regenerator. This product after passing through the heat exchanger enters the solvent regenerator column to lose CO2 and the recovered solvent returns to the absorber to absorb CO2 again. CO2 then enters the first reactor. H2 generation. H2 is generated from water in the electrolyzer. The power for the electrolyzer and other equipment comes mostly from the CH4 which is produced in the plant, by installing a turbine/generator. So the plant would be almost independent in terms of energy, and produces renewable energy. The H2 enters the reactor 1 to react with CO2, using catalyst, and to produce CH4, called synthetic natural gas, SNG. The O2 can be used in other processes of the factory or to be sold. SNG production. CO2 and H2 enter reactor 1. All the reactions are exothermic, so heat is produced. To have a higher yield, temperature must be reduced. Therefore, 2 more reactors are needed in which temperature is less and conversion increases. The temperature of reactor 1 is about 300 C, and pressure of up to 20 atmospheres. The product of reactor 1 is divided into 2 streams, one enters reactor 2 and one is recycled to reactor 1 for better conversion and temperature control. Both the product and recycle are cooled in heat exchanger to lower the temperature of reactors 1, 2 and 3. In reactor 2, more of conversions happens and more CH4 is produced. Temperature is lower than reactor 1, (250 C). Again the product of reactor 2 is divided into 2 streams, one recycle and one product which goes to reactor 3. In reactor 3 an almost pure CH4 is produced. This is called SNG which can be purged to the natural gas grid for use in industrial or residential use. Thanks for your watching.